In this section, we'll cover Cisco device management, which is going to include some of the basic administration tasks that you'd need to carry out on your routers and switches. We'll start off with covering how the boot up process works and the different memory locations in your device. Then we'll move on to how to do a factory reset if you want to wipe your configuration, and how to do a password recovery if you've lost the administrator's enable password. After that, we'll cover how to back up the operating system image and also your configuration. Then we're going to see how to upgrade iOS to a new version, and finally there's going to be a short lecture on how the licensing works. So we've got a lot to cover here. Let's get to it. In this lecture, you'll learn about the boot up process on your routers and switches. And to understand how they boot up, you need to know about the different memory locations on your device. There's 4 built-in memory locations. First up, we have ROM, the read-only memory. Then we have flash. On older devices, that will be installed in the chassis on the motherboard. On newer devices, it's a removable compact flash card. Then we've got NVRAM, the non-volatile RAM, and finally the RAM, the normal random access memory. You can also use an external USB memory stick plugged into the device as well. Okay, so first one is read-only memory, the ROM, and that is what is used when the device is first powered on. ROM has got 2 main functions. First is the power on self-test. The post-test will check for any problems with the hardware. It will then load the bootstrap, and the bootstrap will look in flash for an iOS software image to load next. If an iOS image can't be found in flash, then the device will show the ROM on prompt at the command line. That means the device has failed to boot up if you see a command prompt that says ROM on. The ROM monitor is what it stands for. That can be used to recover a missing or corrupted software image. In that case, you can boot from USB or an external TFTP, Trivial File Transfer Protocol server, to recover the device. And the instructions for doing that can be slightly different depending on the model of router or switch that you need to recover. So to get instructions, just search in Google for Cisco ROM on recovery for your particular platform. We'll have a look at that at the end of the lecture when I do a lab demo. Okay, so we had the ROM memory and then the flash memory. So ROM does the post test and loads up the bootstrap, which then looks in flash memory for an iOS system image. It will load the first image that it finds there by default, but you can override that with the boot system command. Now, when you get the device initially from the factory, it's just going to have one software image on there. But you can upgrade that device because Cisco come out with newer versions of the software regularly. So in that case, you can download the new version of the operating system and then you can copy it down to flash. In that case, you'll have 2 copies, 2 different system images on flash now. So when the system boots up, you're going to need to tell it which one to boot from. It will default to choosing the first one. So to make sure that you get the newer image, the command to use is boot system and then flash and then the system image name. That's a global configuration command. Next type of memory is NVRAM. So when the system has finished loading the iOS system image from flash, it will then load the startup configuration file from NVRAM. And the saved startup config then becomes the current running config in RAM. If no startup config file is found, then the system will load the setup wizard. So if no startup config file is found, it's because you've just factory reset it, or it's just actually come from the factory. Whenever you enter a command in iOS, it takes effect immediately and goes into the running config in RAM. To make your changes permanent across a reboot, we do the copy running config to startup config command, and that copies it into NVRAM, which will be used the next time the system boots up. The reason it's designed like this is so if you're working on the router or the switch and you make some kind of catastrophic error and then you can't get to the switch or the router anymore, you can just pull the power out of the back, put the power back in, boot it back up again, and it will boot back up with the old startup config before you'd made the error in the running config that caused you to lose connectivity to the command line. Okay, the last type of built-in memory is RAM, the random access memory. So the iOS system image and the startup config are loaded from Flash for the system image and from NVRAM for the startup config into RAM during boot up. And RAM is then used as the normal working memory of the device. And if you're wondering, well, why don't we just keep everything in RAM then? The reason is that RAM is volatile memory. It does not survive a power outage or a reboot. So we can't keep the files in there, but we need to keep permanently. They need to be saved in persistent storage like our Flash and our NVRAM. A couple of other things to tell you. First up, the VLAN database. That file is the VLAN.dat file. It's just on a switch where it saves the VLAN information, and that is saved in either Flash or NVRAM depending on the model of the switch. I know we haven't covered VLANs yet. Don't worry, we'll cover that in a later section. I'm just mentioning it now as we talk about the different memory locations. And the last thing, the system can also load a system image and or startup config from an external TFTP server rather than from Flash or NVRAM. That is not recommended though, because the device will not be able to boot if it loses connectivity to that TFTP server. So the only reason you would ever really do that is if you want to load a new version of the system image and there's not enough flash memory capacity on your device to store that, then you can save it to an external TFTP server instead and boot from there. But really not recommended, because if you lose connectivity to the TFTP server, your device won't be able to boot. Okay, so that was all the information. Last thing is to give you a demonstration of all this in the lab. In this lecture, we're going to go through a demo in the lab of the boot up process, and we'll also talk about the different memory locations there again as well. So the lab topology, we've got R1 on the left, which has got IP address 10.10.10.1. It's connected to switch 1, which has got IP address 10.10.10.2 on its VLAN 1 SVI. And we've got a TFTP server on 10.10.10.10. Now, I'm using Packet Tracer for this lab because if you use one of the other virtual labs, it doesn't support playing about with the different images in Flash, but Packet Tracer does. The other way that you can do it is by using real devices, but I didn't want to be messing about with the iOS images on real devices. It's easier to do it in Packet Tracer. So I recommend you use Packet Tracer if you want to follow along with this as well. Okay, so that's what the lab topology looks like. So let's jump on to R1 and have a look at the boot up process. So I'll do a reload and hit enter to confirm. And you can see that read-only ROM-on was initialized first, and then if I just scroll back a bit here now, after ROM-on, it self-decompresses the image. So this is the system image that is in Flash, and it is decompressing it because it's in an archive format, kind of like a zip file. So it decompresses it and it loads it into RAM memory. And then the system will boot up. I press return to get started, go into the enable prompt, and that's the system booted up. After it finished loading the system image, which you can see here, the next thing it did after that was it loaded the startup config from NVRAM again into RAM, the working memory on the router, where it becomes the running config. So on the router here, if I do a show version, I'll be able to see what the system image is. Let me just scroll up to the top of that command, and I can see that this is on a 2900 series router, and I'm running version 15.1 for M4. And if I do a show flash, I'll see that the system image is in there. There it is, and it's the only system image that is there right now. Now, you can actually delete the system image out of Flash. So let's go ahead and do that. So I'll copy the file name here, and I'll enter the command delete flash : and then the name of the file. I'll paste it in and hit enter. It asks me to confirm, are you sure you want to delete that file name? And asks me to confirm again, and I say yes. And if I do a show flash again now, you'll see that the file is no longer there. Now, the system is still up. I can still get to config T. I can still enter configuration commands in here, and the router will still keep running just fine. The reason is that when the system boots up, the system image is loaded from Flash into RAM, and that is the working memory. So as long as the system is up and running, I'm not going to have a problem. A problem is going to come when the system next reboots. So let's do that. I'll do a reload. Yep. And it wouldn't be as quick as this on a real physical router, but you see when it goes to boot up again, it can't boot up. It boots up into ROM-on mode because it wasn't able to find a system image in Flash. So real world, be really careful that you don't do that. Actually, on older routers and switches, it's quite easy to do it, because on some of the older images, by default, if you copy anything into Flash, it will ask you, do you want to delete everything that is already there? And if you're not really thinking and you go ahead and do that, and you're just copying some other file into Flash, then you'll lose your system image that way. So just be careful. Do not delete the system image out of Flash, because if you do, it's a pain to recover it. Let's have a look and see how you do recover it now. So I'll go to a browser. So I've got Firefox open here, and in Google, you see that I searched for Cisco 2900 ROM-on recovery, because that's the model of router I'm on there. And then it's this file here for the 2900, which I've already opened in another tab. And in the section recovering the system image with the TFTP download command, it tells you how to recover the image. So you will need a TFTP server to do this, which we do actually have. I'll show you the TFTP server in a minute. So on the TFTP server, you need to have the system image on there. And then the document that you'll get from the Cisco website will tell you the commands to enter that I'm just scrolling here. And then down at the bottom here, it gives us an example config. So when you get to the ROM-on prompt, the router is not operational. It has not booted up, so it doesn't have any IP addresses on there. The startup config has not been loaded. So you're going to need to configure IP connectivity at the ROM-on prompt. These are the commands to do that. So we enter an IP address for the router. We also enter the subnet mask. You also have to enter a default gateway. If the router is on the same subnet as the TFTP server, then just put the TFTP server's IP address in here. Then the IP address of the TFTP server, and then the file name, the system image that you're going to use to recover that is on the TFTP server. Finally, you put in the command TFTP download. It will then connect out to the TFTP server and download this file and copy it into Flash. The last thing you do after that is enter the reset command, and that will reboot the router, and because you've now got a working system image in Flash again, it will be able to boot up. Okay, let's just have a quick look at the TFTP server in Packet Tracer. So in Packet Tracer, if you go to the End Devices tab down in the bottom left here, and then you can drag up this generic server, which is the third one along in this version of Packet Tracer, and bring it up here. If I click on this now and go to the services, you'll see that TFTP is enabled on that server by default. So there is already iOS system images on the TFTP server. In the real world, then you can download a free TFTP server, or you can use a paid one. There's lots of TFTP software available on the internet. Again, just Google for that and you'll find something. In this lecture, you'll learn how to factory reset your router or switch, and also how to do a password recovery if you've lost the enable password. So factory reset first. The way we do that, very simple. At the enable prompt, we use the write erase command. That will erase the startup config. You do that, you then reload the device, and it will boot up with a blank configuration. There's no startup config, so the setup wizard will then run. Let's have a look at how to do this in the lab. So I'm on my router here, R1. If I do a show running config, you can see the host name is R1 there, and if I do a show startup config, the host name is also R1 in the startup config as well. So that has been saved. So what I'll do here is I'll go to global configuration and I'll say hostname R2. And I'm not doing a copy run start yet. If I break back down to the enable prompt, if I do a show run, I've entered the command. So in the running config, the hostname is R2. If I do a show startup config, you'll see I haven't saved it yet. I didn't do the copy run start yet, so that still hostname R1 there. So if I rebooted now, it would come back up with the startup config. I would lose my unsaved changes and it would still have the hostname R1. What this is useful for is if you lose connectivity to a device that you're working on remotely, you can't get to it anymore, you need to recover it, you can ask somebody in that office to pull the power out and put the power back in. It's not good because it does cause an outage, it's pretty embarrassing, but it's a way that you can get back onto that router or the switch again. Okay, so back to doing the factory reset. I just wanted to show you first about the running config and the startup config. If I wanted to factory reset this device, the command is, I'll do it in full for you, write erase. It will then tell you that this is going to erase the NVRAM file system, which you know is where the startup config is saved, so I'll hit enter to confirm that. If I now do a show start, it will tell me that the startup config is not present, it was erased. And if I reload now and confirm that, it will take a minute to do the reload. And when it comes back up, I can see it's running the setup wizard because it's got no configuration. Okay, so that is how you do a factory reset on your router or your switch. We'll go back to the slides now and have a look about how to do the password recovery. First, you need to know about the configuration register. That is used to change the way that the router boots from the default. You can use the config-register command in global configuration mode, or if you're at the ROM prompt where the router or switch hasn't completed booting yet, you can use the conf-reg command. For example, we could use config-register 0x2142 for that setting at global config, or confreg 0x2142 if we were at the ROM1 prompt. There's several different configuration registers that you can use, probably the three most useful. First is 0x2102. That should be the default. The device will boot normally when that is the setting. Next one is 0x2120 will boot into ROM1 mode, and lastly 0x2142 will ignore the contents of NVRAM while booting, so it will ignore the startup config. Now there are other settings you can use as well, which will mostly change the baud rate, like the rate at which you connect to the device. I can't really think of any reason you would want to do that, so these are the three that you would commonly use. Okay, if we do need to do a password recovery, so this is where we've lost the enable prompt. So maybe it's a small company, we just had one administrator there before, and unfortunately they got hit by a bus, or more happily they've left the company and they didn't let anybody know what the enable password was before they left. Or just as likely is that if you're in a large company, you take a router or a switch out of a shelf, out of a cupboard somewhere, and you don't know what the enable secret is. So it is quite common that you will have to do this. Not day to day, but every once in a while in a real world environment, you will have to do a password recovery. The way you do it is, first off, Google for the instructions for this, because again, you're not going to be doing it every day, and unlikely you're going to remember how to do this off the top of your head. I've done it probably hundreds of times, and I still Google for the instructions whenever I need to do it. So first up is you don't have the enable password, so you can't get into the device, so you need to reboot it. Then while it is rebooting, press the break sequence on the keyboard. That is commonly control break, but it depends on which software you're using to connect to the console. Again, you can Google if it's not control break. Okay, so do that during the first minute that the device is powering on, and that will break you into the ROM1 prompt. You then enter the command confreg 0x2142 at the ROM1 prompt, which says to ignore the startup config on boot. Now, you're not deleting the startup config like when we did the factory reset. The startup config is still there, and the full configuration, everything that was configured on that device is there as well, like IP addresses or whatever. And also the enable secret is still there, which you don't know, but the router is not going to use that startup config when it boots up, so you don't need to know what the enable secret is. You then enter reset at the ROM1 prompt to boot the device. The router will boot up with no configuration, so it will enter the setup wizard. You then type no to bypass that. You then enter enable mode with the enable command. You're not going to be prompted for the enable secret because it's not in the current running configuration, which is blank. Next thing you need to do is copy the startup config to the running config. Do not forget that step. If you forget that step and you do everything else correctly, like it says here, you're going to end up factory resetting that device and you will lose the previous config. If you're doing a password recovery because the administrator left and you need to still have that configuration there, that would be a big mistake. Because you don't forget, to copy the startup config to the running config at that point. That will copy the entire previous configuration into the running config, including the unknown enable secret. But you're already in enable mode, so you don't need to know what that enable secret was. You then enter a new enable secret in global configuration mode to overwrite the old one, and that will go into the current running config. Then enter config register 0x2102 so the router will boot normally on the next restart. Again, don't forget to do this either, because if you do, every time you boot up, it will boot up with a blank config and you're going to think there's something seriously wrong with that router. If you ever get that symptom where every time you boot it up, it looks like it's been factory reset, it will be because the config register is set to 0x2102. Okay, and lastly, we copy run start to save the configuration, and you now are back to where you started, except you're logged in and you've got a new enable secret. Okay, so that's how we do the recovery procedure on a router. If you're on a switch, then it can be a little bit different depending on what model you're on. Also, some routers can be slightly different as well. So whatever kind of device it is that you need to recover, it will be very, very similar to those instructions I just showed you there, but it might be slightly different. So again, Google to get the instructions and just follow the instructions to do the password recovery. Okay, let's have a look at how to do this in the lab next. In this lecture, you'll learn how to do a password recovery from watching a lab demo. When we talk about password recovery, we're talking about recovering from a lost enable password or secret. Now, I know we haven't really spoken about those yet. We're going to cover them in a later section when we get to securing your Cisco router or switch. For now, all you need to know is that you can set a password that is required to get to the enable prompt. So let's actually do that on a router. So I'll go to global configuration mode and I'll say enable password FLACBOX1 and enable secret FLACBOX2. The difference between these is enable password is really a legacy command. Enable secret is the new form of doing it. So if I go end here and do a show run, you'll see the difference is that the enable secret is always in an encrypted form. When you look at the running config, enable password is unencrypted by default. So that could be a security concern. If you've enabled both the enable secret and the enable password, then the enable secret overrides the enable password. So the enable password isn't used. We're always going to use the enable secret. Okay, so our scenario is that an enable secret has been set on this router and we come to work on the router, so we need to get to the enable prompt. So we type in enable, it asks us for a password, and the problem is that we do not know the password and nobody else in the company does either, so we need to recover the password. The way to do it is to boot up the router first into ROM-on mode. Now, the way you normally do that is you power it on, and within the first minute you hit control break, the break sequence, and that will break into the ROM-on prompt. Because I'm on packet tracer here, it doesn't really give me much time to do that. So I'm going to do it from the normal config instead. So I'm going to log in here. If I can remember what the password was. Okay, got it. And I'll go to config T and I'm going to set the config register here. So I'll set it to config register 0x2120, and that's going to boot it up into the ROM-on prompt. Okay, but obviously normally if you're doing a password recovery, you're not going to be able to get to config mode to do it here. So you would be breaking in when the router first boots up, or switch. Okay, so I've done that. I'll end and do a copy run start and then reload, and this is going to boot up into the ROM-on prompt. Okay, so this is how I would do my password recovery. And what I need to do here is tell the router to bypass the startup config when it's booting up. The command for that is confreg, so it's a little bit different than it is at the normal command prompt. And to bypass NVRAM, which is where the startup config is, it's 0x2142. Hit enter and then reset to boot the router. And you'll see that when it finishes booting up, it's not going to ask me for an enable password to get into the enable prompt because it's booted up with a blank config. You can see that's happened because it's booted up into the setup wizard. So I will say no here to bypass the setup wizard, and now I can hit enable, and because it's not using the enable secret from the startup config, it's not going to ask me for a password. Okay, next thing that I need to do is to copy the startup config into the running config. I do that and it's going to copy the startup config in that was already there with all of the commands that were already there, including that enable secret. But I don't need to know it because I'm already at the enable prompt. Okay, next thing I need to do is config t, and I'm going to set a new enable secret. Or for this lab exercise, what I'll actually do is I'll just go no enable secret to remove it. Real world, you would always want to have a secret for the enable prompt on the router, so you wouldn't actually do that. You would actually just set a different secret that you know now so you can get in next time it reboots. Okay, last thing I need to do is a copy run start. And now I'm all good. I've got my existing config on there that was there before. I've reset the password and I'm into the router. And next time that I reload, actually, did I reset the config register? No, okay. I forgot that. This is super important too. Okay, so also at global configuration, do a config-register 0x2102 is for the default boot. Okay, not so deliberate mistake there. If I'd done that in the real world, then what would happen would be next time that I rebooted, it would go back into, I think it was the ROM prompt again, which obviously would not be good. So don't forget to reset the config register as well. End and copy run start. Actually, what you would do in the real world at this point, just to make sure that it will be good when it boots up again, is actually to do a reload. You're not causing an outage because you already had an outage right now anyway. So once you've finished, just reboot it again, take a couple of minutes, wait for it to boot up, and then check that it loads correctly and that you can log in. So go to enable. Okay, and it's asking me for a password. I'll let you in a secret. I actually paused the video when this first happened because I was like, why did that happen? And then I thought, oh, okay, and I realized. So what I want you to do now is pause the video and have a think about it, because I did the no enable secret command and I've rebooted. I didn't forget to do the copy run start. I rebooted and it's still asking me for a password to get into the enable prompt. So have a think about why that is the case. Stop the video for a minute if you have to. When you start the video again, I'll tell you the reason why. Okay, the reason why is that when we did the initial part of the lab, I set an enable password and an enable secret. When I did the password recovery, I just did the no enable secret. I didn't do the no enable password, so there's still an enable password there, and that's what it's asking me for now. Now, in the real world, it's highly unlikely you would run into this problem because you wouldn't do a no enable secret. What you would do is you would set a new enable secret, which would override the enable password, and when you rebooted, it would be asking you for the secret that you just set here. If you remember what we set, it was FLACbox1 for the enable password, so I'm actually able to log in here. If I did a config t now and set enable secret as the new secret of FLACbox2, and hit enter, copy, run, start. At the enable prompt, a copy, run, start. So this is what I should have done earlier in the lab, set a different enable secret. Then when I rebooted, it would have asked me for that new enable secret, which I do know. Okay, hopefully that entertained you, watching me make a couple of mistakes there. I'll try not to do it in the next lecture. In this lecture, you'll learn about backing up the iOS system image and your config file on your router or switch. You can back up either to an external FTP or TFTP server or to a USB stick, or you can back up to flash in the device. Now, reasons you would want to do a backup. you could back up the system image to an off-box TFTP server so that if you need to recover the image later, it saves you downloading it again from the Cisco website. It's going to be handy there already on your TFTP server. Obviously, there's no point in backing up the system image to Flash. It's there in Flash already anyway. Reasons we would take a copy of the backup config is if we want to roll back to that later on. We could again take a copy to an off-box location, or it might be more convenient just to do it to Flash in that case. Okay, if you do want to restore an old version of the configuration file, you can't just copy it into the startup or running config, because if you do that, it will be merged. It's not going to replace it. And if we want to restore, we're going to want to do a replacement, not a merge. So the way that you do that is you first off factory reset the device, you then copy that old config into the startup config, and then reboot, and then you're back with that old config. Okay, the different commands to take a copy of our system image or to take a copy of our config file. Some examples, we could do copy flash TFTP. The iOS system image is in Flash, so that's the command you would use to back up the system image. We could do a copy running config TFTP to save a copy of our config off box on a TFTP server. Another example is copy startup config USB. Okay, so let's have a look at some examples in a lab environment. With the lab, I've got a router at 10.10.10.1 and I've got a TFTP server at 10.10.10.10. First couple of things I'll do is I'll back up the system image and the running config to the TFTP server. So let's go on to our router first, and if I do a show flash here, you can see that the system image is C2900 Universal K9MZ is what it starts with. I just want to show you that it's not already on the TFTP server. So I'll go on the TFTP server and you can see there's no file already there, but it starts C2900. So I want to have a backup of the system image onto the TFTP server. So the way I do that is back on my router, I say copy flash TFTP. It'll ask me for the source file name. I'm going to copy and paste that from the show flash output. Then the address of the remote host is my TFTP server. That is at 10.10.10.10. I want to use the same file name on the TFTP server as well. So I hit enter, and I can see there it goes, copying the file over to the TFTP server. If I now go back onto the TFTP server again and just refresh this, so go back to the services and TFTP, I can see the file is now on my TFTP server. Okay, so that's how you take a backup copy of your system image. If you wanted to take a backup copy of your config, I'll go back on the router again, and for this I will do a copy run to TFTP. We'll copy my running configuration there. It'll ask me where the remote host is again. The TFTP server is at 10.10.10.10. Then it'll ask me what I want to call the file name. I will call this R1-Monday because it's a Monday here today. It's a good idea to put the actual date on there. Obviously a bit more specific than just Monday. Hit enter. It's a really small file, so it takes next to no time to copy. If I go back on the TFTP server and refresh this again, you can see there is the backup of my configuration. Okay, so that's how you back up to a TFTP server. Next one, let's take a backup to Flash and then restore it. So I'll go back on the router and I'll do a show flash, and you can see that I don't have any backup files in there right now. So I'll do a copy actually, let's show you the change happening. So I'm on hostname R1 right now, and I will take a backup of my running config. So I'll say copy run to flash, and let's call this R1-lab for the file name. Okay, and now I will go to global configuration and I will change my host name to R2. Now, I haven't saved it to the startup config yet, so if I wanted to get it back to R1, I could just do a reboot. But as soon as I do a copy run start, that host name is now in both the running config and the startup config. So I do a show run, I can see my host name is R2, and if I do a show start, the host name is R2 there as well. So let's say I don't like this new config and I want to get back to the old config. Really, in the real world, where this is useful is in a lab or a test environment. So say that you want to do some lab exercises and then you want to be able to easily go back to the startup config for the start of that lab. What you do is you set up the starting configuration and then save a copy of it to flash, and then you can then go and make whatever changes you want. Then to get back to that startup config again, what you do is you do a write arrays to erase the startup config. So if I now do a show start, you'll see that the startup config is gone. Then what I do is show flash just to check the name of my backup config, and I'm going to do a copy flash to start. The source file name I will copy and paste. So I will paste that in. It was R1 lab. The destination file name is going to be the startup config, and now if I do a reload, when it comes back up again, with a little bit of luck, it's going to be with the original configuration and the host name is going to be R1. So there you go, that worked just fine. Okay, so that is how you back up your running or your startup config to an off-box server, how you can also take a backup of your config to flash, and how to restore from that if you need to later. See you in the next lecture. In this lecture, you'll learn how to upgrade the iOS system image on your Cisco router or switch. First thing that you need to do is get the new software image. So you get that from the Cisco website at https://software.cisco.com. Let's have a look there. So you land on this page, click on the link for software download, and then that will open up a new tab, and it's searchable in here. So in the search box, put in whatever it is that you want to upgrade. So let's say we want to upgrade a 2960 switch. I put that in, I then select my model of switch. I can then select the iOS image that I want to download from there. So download it from the Cisco website and then copy it onto your TFTP server. Then from the TFTP server, you're going to download it to flash on the device. Once you've got it on flash, then either delete the old image, leaving just the new one there, and the device will now boot up from the new image, or if you want to keep both images on there, just in case you need to fall back to the old one, then to make sure that it uses the new image, use the boot system command. So let's have a look at doing this in the lab. Same lab as last time. I've got a switch this time. We're going to use the switch at 10.10.10.2, and we're going to download a new software image from the TFTP server at 10.10.10.10. So let's go onto the switch and check what software image it's running right now. So if I do a show flash, you see there's only one system image in there. which is running C2960 LAN base MZ 12.2-25. And if I do a show version, not surprisingly, because that's the only system image in Flash, that is confirmed as the software image that we are running. So we're going to upgrade this to a newer version of iOS. So let's have a look at the TFTP server now. And I can see I've got version 15.0 for the 2960. So this is the image that I'm going to use. So I need to download that to my switch. So I'll go back to the switch again, and the command I want to use at the enable prompt is copy TFTP to Flash. The TFTP server is at 10.10.10.10. The file name, I've already copied this into my clipboard, hopefully, so I'll try pasting it. Yep, there it is. That was a 15.0 image. I want to keep it the same name when I copy it to Flash. So there it is, copied into Flash now. I'll verify it's there with a show Flash, and now I can see both the current and the new system image. What I could do now is I could delete the old one, and that will guarantee it will boot up with the new one next time. But let's say I want to keep the old one there just in case I need to fall back to it. I'm going to keep it there to make it easier to do that in case I need to. So I need to do the boot system command now. So I will copy the name of the new system image, and then at global config, I will enter the command boot system, and it's on Flash : and then the file name. Paste that in, and copy, run, start. And I should be good to go now. Now, when the system boots up, it loads the system image into RAM memory. So I need to reload into the new system image. So I will do that now. I will do a reload, and you can see the message there that yes, it is loading the new system image. So that looks all good, but let's just wait for it to boot up so that we can confirm. Okay, there we go. I'll go to the enable prompt, show Flash. You'll see that both images are still there. And if I do a show version, I am now running version 15.0. Okay, so that's all there is to it. That's how you do an upgrade of iOS on your router or switch. In this lecture, you'll learn about licensing. And as engineers, we tend to get more excited about the features and technologies than we do about licensing them. So you'll be glad to hear that this is going to be a pretty short lecture. Okay, prior to iOS 15, different iOS system images were available for different feature sets. So for example, you could get the security feature set for a particular iOS version, or the telephony feature set. And with the security feature set, that would come with features like the iOS firewall and IPS. The telephony feature set would be able to control your IP phones, etc. And back then, licensing was not enforced. But things changed in iOS version 15. Now, rather than coming with different feature sets for the same version of iOS, the new version will come as a universal system image, which includes all of the different features, but license codes must be entered to activate those different technology packages. When you purchase a license, you'll be provided with a PAC code that stands for Product Activation Key. But you can't just put any PAC code on any router, so you can't reuse it on multiple routers because the PAC code is not the license. It's used along with the UDI to generate the actual license. The UDI is the unique device identifier. So you buy the license, you get a PAC code. You then need to tie that to the UDI to make sure that you can only run that license on one particular device. And the way that you tie the PAC code and the UDI together to generate the license is you go to the Cisco license portal on their website. You can see the URL is cisco.com/go/license. So you go there. In fact, let's have a look at it. So you go to the website, that will open up the license registration portal once you've entered your Cisco username and password, and from there you can enter your PAC and your UDI and generate your license code. Once you've got your license code, then you go back to your router and copy it to Flash. The way you get the license is after you've registered it on the portal, you'll receive the license in an email. So from the email, copy the license to a TFTP server and then copy it onto Flash from there. Then to actually install the license, the command is license install Flash. And then once you've got your licenses on there to verify them, the command is license show. Okay, that's all you need to know on licensing for the CCNA exam. See you in the next lecture when we're going to be back to the technologies again.